Hi all, this is Lakshmi working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on electronic circuits, and the topic which I'm going to discuss here is all about transistors. So as we all know that our human brain has billions of cells which performs various functions. Similar to that, a computer also has millions of transistors which is responsible for various functions. So transistor is a fundamental semiconductor device which is used in most of the electronic devices. So let us discuss in detail about transistors. So this is a device which is made of three layers of semiconductor material. So which is acting as an insulator and a conductor. So there are three terminals in the transistor. You could see here. So this terminal is the base, and this arrow indicated terminal is the emitter, and this is the collector. So these are the three terminals of the transistor. So and this is the symbol of a NPN transistor. So these three terminals, the functions are, this is the terminal base. So base is normally it is thin and it is lightly doped. And whereas this terminal emitter is heavily doped and it is moderately sized. And collector is a terminal which is larger in size and it is moderately doped. Base is slightly doped, emitter is heavily doped, and collector is moderately doped. This is how the structure of a transistor will be. And we call this as bipolar junction transistor. The reason is that the current conduction here is due to both the charge carriers, that is the majority and minority charge carriers contribute to the current conduction. Hence it is called bipolar junction transistor, and normally it is a current controlled device. BJTs are current controlled device. And the main function of the transistor is that it is acting as switch as also and also as an amplifier. So before learning about the transistor, the need for transistor, so we must know why we learn this transistor and where it is being used. So as in the beginning I told, so billions of transistors will be there in a computer's the processor. So how it is acting as an amplifier and switch. So that is the main application of transistor. So we all know that amplifier means a weak signal is converted into a strong signal. So boosting the signal strength is called as an amplifier. So here is an example of an amplifier circuit. So when we talk through the mic, so the signal, our voice is converted into the electrical energy with the help of mic, and then which is mic is a transducer, and then it is given to the amplifier, and at the towards the end at the output the loudspeaker gives us the uh, amplified signal. So that loudspeaker is another transducer which converts back the electrical signal into sound signal again. So thus amplification is achieved. So transistor is acting as an amplifier as well as switch. So you could see here how it is acting as a switch. So this is the picture for transistor acting as a switch. You could see, so when I press the switch, the LEDs, the current flows and LEDs are going, and the switch is off, the LEDs are off. So in this way, the transistor is mainly used as an amplifier and switch. So there are two types of BJT. So one is PNP and the other one is NPN. So there are three terminals, as I told, base, emitter and collector. So the difference here is only the polarity varies. So you could see that here the current flow is towards, in PNP, towards the base terminal, whereas in NPN, we could see that the current flow is outwards. So this arrow differentiates whether it is PNP or NPN based on the current flow. So this is the basic structure of a BJT. So initially we have a substrate, and as we discussed, there are three terminals: collector, base and emitter. Then we have a metallized contact, and then an oxide layer. So here, as I discussed in the previous slide, so we could see that N PN. So this will have N-type collector, P-type base, and N-type emitter. So here the junction is formed in a BJT. Two PN junction will be connected back to back. That forms the transistor. So we have learnt about PN junction diode. So when two diodes are connected here, we'll get a transistor. That is, two PN junctions are connected back to back. So there are two PN junctions forming here. So one is a base collector junction and the other one is base emitter junction. So similarly for PNP, only the difference here is the polarity varies. So to understand the operation of the transistor, I have compared an example here. So the water flowing through the pipe can be taken as an example. So we have a valve here. So this is acting as a base, and the water flow which is coming towards this valve will be the emitter terminal, and the outlet is the collector terminal. So based on this valve that is acting as a base, the amount of water which is coming through the outlet depends. So if the valve is if it is open, we could see that complete water flows out. If it is closed, similarly, the amount of water which is coming out will be reduced. So similarly, in this way, in a transistor, the base current controls this device. That is why it is called current controlled device. This base output current here, the collector current, will be controlled by the amount of base current through this terminal. So I think it is clearly understood with this example that the base current controls the collector current. The output current here is controlled by the input base current. Hence it is called as current controlled device. So now let us discuss the working of the NPN and PNP. So as I told, there are two PN junction here. So one will be the emitter base junction and the other one is collector base junction. So first is our PNP is given here. So first what I'm doing is I'm making my emitter base junction as forward bias. So this is P type, which is having majority of holes. So I'm connecting it to positive. So which means that this is the forward bias connected. And our collector base junction is reverse bias. This P type is having majority holes. I have connected to the negative terminal here. So thus this part is forward bias and this part is reverse bias. So what happens is when the current starts flowing here, all the holes present in the p-type material due to the force of attraction starts moving towards the base terminal. As this base terminal is thin and it is lightly doped, few of the holes will combine with the electrons and the rest will flow to the collector. So collector is the terminal which will collect the charge carriers from the which is given from the base. So here this contributes our collector current. So similarly, in PNP, the same occurs. Only thing is the polarity will get reversed. So this part is the emitter current and this is our base current and this is our collector current. So we know that. So when you apply the Kirchhoff's current law, so we would get that the sum of the base current and the collector current will be equal to the emitter current. So this is the how the current flow works in the NPN and PNP transistor. So this is the animated part of how the depletion region varies in a transistor, in NPN transistor. So you could see how the charge carriers are moving towards the base terminal and what happens to the depletion region. So today's assessment is discuss BJT and its types. So BJT, as I told, it is a three-terminal device, which is a current-controlled device, and the three terminals are base, emitter, and collector, and the two types are PNP and NPN, and there are three configurations of this BJT: common emitter, common base, and common collector. Thank you.